okay? All right, so I'm just going to go through this real quick. When I'm done, you have the rest of the time in class to work on your decimals project or your delta math for the rest of the hour, okay? All right, so here we go. We'll start with number one. It says classify the polynomial by degree term and give the leading coefficient. In this case, the highest exponent is 5, so that is a quintic. There's two terms here, so that is a binomial with a leading coefficient of -3. This leading coefficient is always the number in front of the variable with the highest exponent. Okay, for number two, maybe make this a little bit bigger. There we go. For number two, same situation, classify it. In this case, it's to the second power, so it's quadratic. There's three terms, so it's a trinomial with a leading coefficient of 2. Now, for number three, I want to rewrite this into factored form. So in this situation, it's what two numbers add to give us -13, multiply to give us 36. Since the b is negative and the c is positive, both values are going to be negative. In this case, it's -9 and -4. Since our a value is 1, our factors are just going to be x minus 9 and x minus 4. Then for number 4, for this one, we have an a value that is greater than 1. Okay, it's 20. So now we're going to use Manzo AC. So it's what two numbers add to give us 7, multiply to give us 20 times -6, which is -120. I believe that this was 15 and -8. So you're going to take 15, -8. You're going to put them both over the a value of 20. Now, for each of these, you want to simplify them down. I'll leave them in fraction form. 15 over 20 reduces to 3 over 4. -8 over 20 reduces to -2 over 5. Put x's in the denominator. And now start at the bottom, work your way up. So you're going to get 4x plus 3 and 5x minus 2. And then y equals. All right. All right, then for the next one, number 5, rewrite this into standard form. Remember, standard form is ax squared plus bx plus c. So how do we do that? We just take these two factors, put them in the box, and multiply them. All right, so I have 2x minus 1, and I have x plus 5. So let's multiply. X times 2x is 2x squared. X times -1 is -x. 5 times 2x is 10x. 5 times -1 is -5. Our like terms are -x and 10x, which is 9x. So this is going to be 2x squared plus 9x minus 5. But of course, y equals in front. All right. Okay, next page. For number 6, same situation. Want to put it into standard form. Ax squared plus bx plus c. So first things first, you got to do order of operation. You got to start with this portion here first. X minus 1 quantity squared. Well, x minus 1 quantity squared is x minus 1 times x minus 1. So if we want, you can use that box method. Okay, so you have x and minus 1, x and minus 1, and then multiply. You're going to get x squared minus x here, and then positive 1. Because remember, negative times negative is positive. So if I combine these together, I'm going to get x squared minus 2x plus 1. Now that is going to be multiplied by the 3 in front and then subtracted by 3.5 on the end. So now I want to distribute the 3. So I'm going to have 3x squared minus 6x plus 3 and then minus 3.5 on the end. All right, 3 minus 3.5 is negative 0.5. So this is 3x squared minus 6x minus 0.5. With y equals in front, of course. All right, number 7. In this case, I want to put this in the vertex form. So first things first, let's identify what the vertex is. The vertex is right there. So that's at -1, 2. Our a value, if I go 1 to the right, I go down 1. So my a value is -1. All right, a lot of students miss that, okay, because it does open down, so your a value should be -1. So now, in vertex form, y equals a times the quantity of x minus h squared plus k. My h and k value are -1 and 2. My a value is -1. So y equals negative 1, so negative, times the quantity of x minus negative 1, which is plus 1, quantity squared, and then plus 2. All right, number 8. If I have y equals x squared plus 8x plus 15, if you remember, given standard form, how do I find the x value of the vertex? Find the x value, it's the opposite of b over 2a. Also, you could have plugged that into the calculator and graphed it and then figured out where the vertex was from there as well. So negative 8 over 2, in this case it's going to be negative 4. Plug in negative 4 for x, solve for y, you should get negative 1. The a value is 1, so you don't have to worry about that. Write it in vertex form. This is y equals the quantity of x minus a negative 4, which is x plus 4 squared minus 1. Then for number 9, we want to simplify this, all right, and state any restrictions. Well, you can start with the restrictions here. You have x plus 9, x plus 4, all right, set them both equal to 0. So x cannot be negative 9 or negative 4. Get that out of the way, okay? Now, we want to factor the top. What two numbers add to give us 12, multiply to give us 27? This is going to be 3 and 9. So this is x plus 9, x plus 3. That's on the top. On the bottom, we have x plus 9, x plus 4. So in this case, on the top and the bottom, what do they have in common? X plus 9. Those cancel. You're left with x plus 3 over x plus 4. And I needed to have both of these situations. All right, 2 pages down, 2 more to go. Here we go. Next page, number 10. Okay. What is the ball's height? Okay. After 4 seconds. That's pretty much what this h of 4 is. So h of 4 is going to be negative 4.9 times 4 squared plus 175. You should have been able to just type this entire situation into your calculator. All right. But remember, order of operation. It's going to do 4 squared first, then times by negative 4.9, then add 175. H of 4 is going to be 96.6 meters, and that's the height after 4 seconds. Number 11. Now we want to solve by factoring. Once again, your a value is greater than 1, so we're going to do Manzo AC. So it's what two numbers add to give us negative 19 multiplied to give us 60. B is negative, C is positive. Both values are going to be negative. I believe it was negative 15 and negative 4. So now we take negative 15 and negative 4. We put them both over 10, our A value. Simplify them. You're going to have negative 3 over 2 and negative 2 over 5. Now, from here, because of the fact that you did show me factoring right here, if you left them as x equals 3 halves and 2 fifths, all right, you were done. Otherwise, if you kept going and did the factors, okay, put x's on the bottom, you're going to get 2x minus 3, and you're going to get 5x minus 2. Now, those are both set equal to 0. So it's 2x minus 3 equals 0, 5x minus 2 equals 0. Solve for x on both. Here, you're going to add 3. All right, you get 2x equals 3, then divide by 2. So x is 3 halves. Same situation here. You're going to add 2 and then divide by 5. X would be 2 fifths. Number 12, solve the equation. All right, leave the answer in radical form. So basically, you could have done the balancing method. You could have done the undoing method. It was up to you. Okay. First things first, you're going to add 2 to both sides. You're going to get x minus 4 quantity squared equals 15. Take the square root of both sides. You're going to be left with x minus 4 is equal to plus or minus the square root of 15. And then finally, add the 4. You're going to get x equals 4 plus or minus the square root of 15. And that is leaving it in radical form because you cannot take the square root of 15 evenly. 13, same situation. Okay, first things first, we're going to start by subtracting 16 from 6, which is negative 10. So this is negative 2 times the quantity of x plus 4 squared equals negative 10. Now, from here, we want to divide by negative 2. Negative divided by negative is positive. All right, so I'll move this up. So x plus 4 quantity squared equals 5. Then, just like we did before, take the square root of both sides. You're going to get x plus 4 is equal to plus or minus 5. And then subtract 4. So x is going to be negative 4. plus or minus the square root of 5. So hold on, this should have been a square root right there. Okay. So that is our answer for number 13. All right, last page, almost done. Okay, 14 and 15, you want to solve by completing the square. So for the first one, remember, we want to get that c value out of there, so I'm going to add 10 to both sides. This gives me x squared minus 2x is equal to 15. Now we complete the square. Take the b value of negative 2 divided by 2, which is negative 1, square it, which is positive 1. Remember, we always add the c value. Add it to the left, add it to the right. Now, our perfect square trinomial here breaks down to a squared binomial. What two numbers add to give you negative 2 multiplied to give you negative 1? That's going to be negative 1 and negative 1, or x minus 1 quantity squared. Equals 15 plus 1, which is 16. Then from there, take the square root of both sides. X minus 1 is equal to plus or minus 4. And then finally, you're going to add 1. So if we add 1, you're going to get 1 plus 4, 1 minus 4 gives us two answers of 5 and negative 3. Do the same situation for 15. All right? We'll start by adding 3 to both sides. So x squared minus 4x is going to equal 3. We want to divide that by 2 and square it. So we're going to end up adding 4 to the left, so we add 4 to the right. Perfect square trinomial breaks down to x minus 2 squared. That's our squared binomial, equals 7. Right. Then we just go about solving. Take the square root of both sides. You're going to be left with x minus 2 equals plus or minus the square root of 7. And then we add 2. I'll change the color of that. So we add 2 to both sides. So you're going to get x equals 2 plus or minus the square root of 7. And that is an exact answer because you can't take the square root of 7 evenly. You'd be left with a decimal. And we don't want to round decimals. Okay, that's not exact. All right, last two using quadratic formula. So quadratic formula, if you remember, x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So if you sang that song, all right, hopefully a lot of you were singing it, okay, you cannot forget it, all right? All right, so in this case, we plug in our b, our a, and our c values. So x equals, this is going to be negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times 1 times 4, which is 16, all over 2 times 1, which is 2. Now, 4 minus 16 here is going to give us negative 2 plus or minus the square root of negative 12 over 2. So, because of the fact it's a square root of negative 12, that'd be no real solutions. If you put that, you were fine. Now, if you wanted to actually break this down to an imaginary solution, this would have been negative 2 plus or minus I square root 12 all over 2. Square root of 12 breaks down to square root of 4 times square root of 3. Square root of 4 is 2. So we could have simplified this even more to get negative 1 plus or minus I times the square root of 3. However, I was just looking basically for these answers right there. All right, finally, our last one. I have 5x squared plus x minus 9. Once again, x equals opposite of b, so negative 1 plus or minus the square root of 1 squared, which is 1, minus 4 times 5 times negative 9, which is plus 180, all over 2 times 5, which is 10. 1 plus 180 is 181. So this is negative 1 plus or minus the square root of 181, all over 10. And you can't simplify it down anymore, so you just leave it like that, okay? Now, I think some students actually tried to divide this, and I definitely would not do that. I would just leave it alone. But some of you tried to, and you ended up with this, negative 0.1 plus or minus the square root of 18.1, which is not correct because the square root of 181 divided by 10 is not the square root of 18.1, okay? So you could not do that. You can do the front part, negative 1 divided by 10 to get negative 0.1, but not the secondary part. So I would just leave it like this. All right? Okay, so like I said before, retakes, get those delta maths done. We'll start retakes Monday in STAR. Please let me know if you have any questions. Remember, your Desmos is due tonight, 11:59 p.m., along with your delta math. All right? Thank you very much, guys. Have a good one. I'll see you soon.